So 1, 2, 3, 4, 5, 6. So we've drawn a type of hex. Oops. Sorry. So we have a hexadiene because we have two bonds. All right, and this would be 1, 2, 3, 4, 5, 6. 1, 2. It doesn't matter which way we number it. So I have a double bond off the 2. Okay, and that double bond is trans, so I would have trans 2. And then this double bond would be cis 4 hexadiene. Okay, so you would just put your trans in front of your numbers. Okay, if you had more than one double bond. Okay. So these are called cis-trans isomers. It's our second type of isomer that we have to be able to deal with. There's going to be one more, all right, but we're not quite ready for that. All right, so the next thing that we're going to deal with, our next homologous series, but we're going to start talking about rings. So we're going to talk about our cycloalkanes. All right, so these are alkanes, so all single bonds, that are in a ring structure. Okay, so the general formula for our cycloalkanes is going to be C to the N, H to the 2N. The smallest cycloalkane you can have is a 3-carbon ring. Now you can have really big ones, all right, and we'll talk a little bit about those, but the smallest you can possibly have is a 3-carbon ring. Now, how do we name these? We're going to count the number of carbons in the ring. And then we're going to add, cyclo as a prefix. So let's start with that 3-carbon ring. Okay. 3 carbons is propane, so this would be called cyclopropane, and it would look something like this. So we got 3-carbon ring. Okay, this is cyclopropane, and it would be C3H6. Okay, now we'll often use shorthand. Okay, so the shorthand for this would just be a triangle. And at the points, you have carbons. So at each point is a carbon atom. So I'd have a carbon here, carbon here, carbon here. So that's our 3-carbon ring. So what would this be? have a carbon here, carbon here, carbon here, carbon here. So it would be this. We'd have hydrogens. So this is a 4-carbon ring. There it is. Okay, so this would be cyclobutane. Okay, we could keep going. Oh, let me see if I can draw this. Not bad, not great. Okay, so this would be cyclopentane. Okay, and we could do this would be 1, 2, 3, 4, 5, 6 carbons, all single bonds. So this would be cyclohexane. So we can name these now. Now, some things about rings. Three or 4 carbon rings are called small rings. 5 to 7 carbon rings are called common rings. 8 to 11 carbon rings are called medium rings. And then 12 or greater are called large rings, or sometimes they're called macro rings. Macro rings. Now, when we study these, okay, when we look at these different sized rings in our cycloalkanes, common rings and large rings have almost identical properties as the alkane it comes from. So if you take organic chemistry, you'll learn that there's relationships between our cycloalkanes and the carbon chain alkanes. Okay, so for example, all right, let's take a common ring. I don't know, let's use cyclopentane. Okay. In a sample, there's actually a relationship between these. But the properties end up being the same. Okay. They end up being the same. And that's only true for your common rings and your larger rings. Your small rings and your medium rings, not so much. And we'll kind of talk about that. Why do our small and mediums behave differently? So our small and medium rings have very different properties from the alkane they come from. Let's talk about small rings first. So remember, in our carbon compounds, these go through sp3 hybridization to give us that tetrahedral shape. But when that happens, we want 109.5 degrees of angle. Well, if we have a small ring, a 3 or a 4, what is this angle? And what is this angle? Well, this one, it's about 90 degrees, all right? And this one's even smaller, all right? So these have very small angles, okay? Less than 109.5 degrees. Okay, do you think these carbon atoms right here on this corner, do you think these carbon atoms like that? The answer is no. They want 109.5 because of that repulsive force between all of those electron domains. Right? So this is a very stressful situation for these carbon atoms. Okay, all 4 of them. Because it's got a 90, this has got a 90, this has got a 90. Right? So because of this very small angle, it makes these small rings very unstable. And these rings tend to fall apart. Now our medium rings. And these are only the ones in 8 to 11. And these are just weird, and each one is kind of individually different. But they can do some weird things. So like cyclohexane. So cyclohexane, comes from N-hexane. But it turns out that it has 2 different forms that it forms. Okay, so this is one cyclohexane. But I'll actually make a different one too. I think it's called a boat, and it does something weird like this. So we get this, and then it goes boop like this, and then it comes down like this, and then it's straight across like this. And then it goes like this. And we have carbons here, 2, 3, 4, 5, 6. Okay, this is also a type of cyclohexane. They have very different properties. Okay, and you can tell because just by the structure themselves, they're going to have very different properties. And they're going to have very different properties from the alkane. 1, 2, 3, 4, 6. And each one of our medium rings does stuff like this, and it just does weird things. So they have very different properties from the alkane itself. Right, so I just wanted to show you those. Let's do one more thing with the cycloalkanes, and then I think we'll call it a day. So we can put side chains on a cycloalkane. So for example, we can have something like this. So I have a methyl group coming off of my cycloalkane. So to name these, we're going to name the cycloalkane. And then use the functional group rules that we learned. Now when we number these, you number it so it has the lowest, comes off the lowest possible carbon. Now in this case, if we only have one group, this is always going to be 1. All right, so if we're to name this, this would be a cyclopentane. It would be methyl cyclopentane, and technically it's 1 methyl cyclopentane. Okay, I wouldn't put the 1 in there. I mean, you could, but I wouldn't, just because if I only have one side chain, it's always going to be 1 methyl cyclopentane. All right, what if we have something like this? So now I have a halide. I start by naming my cycloalkane. 1, 2, 3, 4, 5, 6. So this is a type of cyclohexane. Now, how would I number this? Well, we're going to go in alphabetical order, so this one's less than this one. So I could number it 1, 2, 3, 4, 5, 6. Or I can number it 1, 2, 3, 4, 5, 6. Right, so we're going to number counterclockwise. So this would be 1 bromo, 3 chlorocyclohexane. Let's name this one. Okay, so this would be a cyclopropane, and I would have 1, 2 dibromo, 3 iodo cyclopropane. All right, so that's where we're going to stop for today. Make sure you're working on all the stuff that I give you, and we will keep going with aromatic compounds, and we'll get into organic reactions next time. All right, have a good one.